Guys, today we are going to discuss about basically basic of NLP, you can say. And let me share my screen so that I can show you the syllabus, and then we can start with the discussion. So yesterday I was talking about basically this transfer learning, right? So this is what we have discussed, and we have seen that how we can do a transfer learning and fine tuning of some of the already pre-trained model. And we have basically done a transfer learning or fine tuning with respect to ResNet 50 model. This is what we have discussed. Now, in my today's class, so I'll be talking about a complete theory and a mathematical intuition behind this entire things. So first of all, I'll be talking about RNN. So before even talking about RNN, so I'll be talking more and more about that why RNN is required and what kind of a problem RNN is trying to solve, which was not like solved by CNN, right? So CNN classification model, at least that we are trying that we have already understood. And then I'll be talking about a variant of RNN, which is a LSTM, and then a variant of a GRU. And then I'll be talking about one mother of everything, I would say, a research paper called as like attention is all you need. So that is a research paper which is a mother of each and everything, I would say. And this is where you will be able to see attention mechanism, transformer, and that research paper when I'm going to like discuss with all of you again. So not in a research paper way, but whenever I'm going to discuss with you, so I'm going to discuss with you in a very like intuitive, in a very layman way, and so that you all will be able to understand that how things are actually working, and then you will be able to understand almost every kind of architecture which exists today even in a modern world. So whether it's a chat GPT that we are talking about, or maybe a llama that we are talking about, a Gemini that we are talking about, or any other such kind of LLMs that we are talking about in a current situation, so everything you will be able to understand. And that is something like the objective of this entire section is, but not today. I'm not saying that today you will be able to understand. As we will progress, so here you can see a bird GPT and like a T5, all of these models. So as we will progress, you will be able to understand. So mostly by next week your understanding will be pretty much clear that what attention mechanism or attention is all you need is trying to do, what kind of problem it is trying to solve, and how we are able to build a chat GPT. Even in some of my class, so which is nothing but generative AI class, so we have done a small experimentation and we have built our small version of a chat GPT. So even we have done that in a class itself, we have done that. So most probably, so we'll try to do similar kind of a stuff even over here. But yeah, so that class is already available. I believe I have even uploaded those videos over a YouTube, so you can go and watch that video. So where I'm talking about the practical manner, basically, where I'm talking about everything in a very, very practical manner in terms of building a small version of a chat GPT with my own data set. So without like taking a data set from outside, with my own data set. So we are training the chat GPT. Plus, even I have discussed about like under the hood technology, what kind of a technology which has been used inside the chat GPT. So fine. So like today, let's get started with first topic, which is basically a introduction to RNN basically, and why we need RNN kind of a model. So why not CNN? So even CNN can learn things, right? So CNN can solve a problem. CNN will be able to extract features, and we have already discussed about like a convolution over there inside a convolution. So we talked about filters or kernels, you can say in other way. So we talked about everything, and again, so CNN was good in terms of learning the pattern, and that to a complex pattern which we used to find out in case of our images. It was able to extract a feature, so it was very good with that. Again, if I'll talk about a model like ResNet 15, so obviously those models are way better as compared to like any other model that exists in terms of understanding a complex images in terms of giving you the final result. But still, why do we need a different kind of architecture? So what was a problem with a convolution neural network, and what problem can we solve with the recurrent neural network? So we are going to basically talk about that particular part. Making sense, guys? So anyone who is having any confusion, any concern, so please go ahead. Yeah, making sense, guys, to all of us? Fine. Okay, and please keep on pinging me in a chat if you're not able to understand some of the topic, because these topics are very much important. Again, so fundamentals, like I keep on saying that fundamentals are very much important for every topics. And if your fundamentals are clear, even tomorrow, doesn't matter what kind of a technology comes into a market, you will be able to understand by yourself. You don't need me even tomorrow, right? So when you will try to understand something new which will come into the market. But yeah, if your fundamentals are not clear, if you are just trying to like go through the things on an overall basis, then obviously whenever new things will come into a picture, you need people like me. I don't think that which is required. Maybe you can like just clear out the fundamentals once. Yeah. Okay, so let's get started, and let's try to understand that what this like RNN is. And before that, before even starting with RNN, so let's try to talk about what was a problem with the CNN, and then why we are talking about RNN. So see guys, in a very simple word, I'll try to explain you that what was a problem with the CNN. CNN that we have already discussed, and then I'll be talking about that how RNN is going to work, how RNN is going to solve the problem. So let me open up my Scribble ink over here, and then a new one. Okay, so basically when I talk about a CNN, right? So we have already discussed a network. So CNN will try to go with the forward pass, and in a forward pass, so it will always try to extract a feature. This is what we have discussed since a very, very long time. So it will try to extract a filter. It will try to apply some sort of a pooling. It will try to apply some sort of a non-linearization on top of the data. So whatever data that it is trying to extract. But can I make a statement over here that when it will go for the next lap, for example, so let's suppose we have a CNN neural network. I'm just trying to draw the rough CNN network. Let's imagine that we have like a CNN. So we are trying to like do a convolution pooling, convolution pooling with respect to images that we have. So let's suppose we have this images, and we are trying to perform some sort of like a convolution with this one. So let's suppose we are trying to extract the feature, and then sequentially we are trying to like build the next one, and then the next one, and the next one, and then we are trying to send those data into the feed forward. Yeah, so this is something that we are trying to do, let's suppose. Now, can I make a statement over here that when system is trying to go through a forward pass, right, forward pass, it is trying to extract a feature, right? It is trying to extract a feature, and then obviously here it will try to calculate a loss, right? And based on the loss, so it will try to do a backward propagation. This is what we have discussed since the very beginning. So it will try to do a backward propagation over here. Now in backward propagation, so it will try to update all the weights, and obviously like we have a kernels over here, right? So kernels are also a trainable parameter. Filters are also a trainable parameter, whether it's a 3x3 filter, 5x5 filter we are going to take. So all these parameters are basically a trainable parameter. So it is going to change those kernels as well. And this is something called as training in case of what? In case of convolution neural network. Doesn't matter what kind of a convolution neural network we are going to build, whether it's a vanilla convolution neural network or maybe a ResNet kind of a convolution neural network. But yeah, this is something which is going to happen. Now, so just answer me with yes or no that when I'm trying to, again, let's suppose there is a pass, forward pass number 1. Now let's suppose I'm going through a forward pass number 2. Now, so when I'm trying to go through a forward pass number 2, is it going to consider a previous memory? Is it going to consider the previous input or previous state in case of a convolution neural network? Yeah. Yes. Is there any dependencies between pass number 1 and pass number 2? Do we have a dependencies between a pass number 1 and pass number 2, means the previous one and the new one? So when I'm trying to go through a network now, and when I'll try to go through a network next time, so is there any kind of a dependencies we have? Is there any kind of a relationship we have? Yes or no? So yeah, most of you, MCK, Durgesh, Mali, Amrendra, Sai, Saswat, like everyone is saying no, right? Ganesh, everyone is saying no basically, right? Any reason, guys? Yeah. So we have seen that in case of a CNN, so there will not be any kind of a dependencies, or you can say that there won't be any kind of a relationship. You will be able to find out between a previous state and the current state, right? But let's suppose I'm talking about this lecture, right? I'm talking about this lecture. Can I say that we have a relationship between a previous class and this class? Yeah. Can we say that we have a relationship between this class and the previous class? Can I say that whatever next line, right? Whatever next line which I am trying to write down on my screen, or which I am trying to speak as of now, is having a dependencies with my previous line? Yeah. So can I say that when we as a human being try to build a conversation or try to do a conversation, so we always and always try to rely on a relationship with a past. Whatever I'm trying to say next, obviously it will be having some sort of a dependencies with my past. I'm going to take some sort of a inspiration. I'm going to take some sort of a maybe like a input thought in thoughts basically, and then I'll try to do some new prediction, or I'll try to say something new out of it. And this is what, right? So this is what basically the CNNs was lagging. So it was not having a state awareness. Basically it was not having a dependencies with a previous one. So every lap is going to be a independent lap. So it will just try to do a backward propagation, and then it will try to adjust the weight so that it will be able to reduce the loss. But it will not be aware about any kind of a things which has happened before and what is going to happen next. And that is a problem, right? So that was a problem, and because of that problem, so we are now talking about a new kind of a network, right? So convolution neural network, when we say, so yeah, it's very good. It's very good in terms of dealing with the images, but right, but when we talk about when we talk about a chains, when we talk about a series, like a time series, I would say, when we talk about a language speaking or language learning, so in that context, CNNs are not that good. It will not be able to understand a relationship between like a data or words, you can say, or maybe a grammars. It will not be able to understand that what should come after, what should come before. All of these stuff, CNN's kind of a network will not be able to understand, right? But yeah, it's good again in terms of understanding the complex, like a relationship between the image data set, or even like other data set I can try to take, because at the end of the day we are talking about the matrices. So this is where RNN people have introduced. And RNN means, what is the meaning of this RNN, or what is the full form of this RNN, by the way? So the full form of this one is a recurrent neural network. RECURRENT, recurrent neural network. So this provides you a different series of a neural network. Convolution is having its own series. We have already discussed about it, right? So starting from a LeNet, LXNet, VGG series, and then like a ResNet series, GoogleNet series, a DarkNet series. So there are so many series you will be able to find out in case of convolution neural network. More or less every model is trying to do some sort of a convolution, and we all understand that what is the meaning of convolution? Filters, right? So we try to apply a filters, or in other word, it's a kernel that we try to apply, and eventually it will try to like understand the edges, or maybe like shapes, or maybe like different color gradients inside the images as a feature, and it will try to do its own learning. Now here, so we are talking about a complete new kind of a neural network, and which is basically a recurrent neural network that we are going to talk about now. So what recurrent neural network can eliminate, or what kind of a benefit you will be able to get with respect to the recurrent neural network? So recurrent neural network always try to process a data into a sequential manner. First part. Second part is, so it will always try to maintain a memory across a steps, means it knows, like it is having some sort of information that what has happened in a past, and then what is a relationship of a past with a current. So basically time t minus 1 and time t. So it will be able to understand a relation. It will be able to establish a relationship between time t minus 1 and time t, or even more, right? For like a longer period, it will be able to understand, and which is very much required for a conversation, right? Which is very much required for a conversation or human like a conversation. And this is what ChatGPT is trying to do, right? But yeah, we'll not come to ChatGPT as of now. We'll come to that in a very, very later stage. But yeah, let's try to understand first of all recurrent neural network. So here, recurrent neural network is always try to process the data into a sequential manner. It will always try to maintain a memory across a time, I would say. And then it's very much good, I would say, for languages. So in terms of language learning, language understanding, understanding a grammars in between or a speech, or I would say even it's good for a time series. Majorly it's good for time series nowadays, because for languages we have now a transformer based model which is way better than this RNN that we are talking about, right? RNN will be able to handle different length of the input at the end of the day. So here, why we are talking about RNN? Because it can maintain the memory, it can maintain the state. It knows that what has happened before, and based on that, it will be able to do something next. So here, right? So here in general, over an internet, you will be able to find out this kind of a very simple architecture. So here you will be able to find out something like this, so I'm going to give a input, let's suppose add x, and then I'm going to get a output, let's suppose as O, and then we have a weight over here, we have a hidden state over here, and then it's looping to, okay, it has created a circle, so it's looping to itself. So this kind of a structure you will be able to see in case of a RNN in general, right? In general. Now, when you are going to unfold this kind of a structure, so what you will be able to see, so when you are going to unfold this structure, so you will be able to see something like this. Let me show you that part as well. So here, let's suppose if I'm trying to give a input x t minus 1, and then I'm going to give a input x at t, and then I'm going to give, let's suppose, input at x time t plus 1. Okay, now, so everything will be connected to each other. Everything will be connected to each other. Now, this is a hidden state at t minus 1, hidden state at t, and hidden state at t plus 1. And then here, so you will be able to get an output basically. So you will be able to get an output in this particular place. So output at t minus 1, output at t, and then output at t plus 1, and obviously with the weight. So we'll be having weight here, and weight here. So ideally we are talking about a neural network, right? So in a neural network, so which will be able to pass a data into a sequential manner, which will be able to give like a input into a sequential manner. And here, so you will be able to see that the next one, this state which is trying to take the input. So yes, it is trying to take the input, a new input, but it is also trying to take the input from the old one, from the previous one. So let's suppose I'm trying to call that as a V and V over here. So it is not just trying to take the input from the current state or anyone, right? So any one of this is not just trying to take the input from the current state. It is trying to take the input from the current state, but it will also try to take the input from the previous state. So technically it's trying to take two input at a time in general. So if I'll talk about a CNN or whatever neural network that we have discussed so far, even the basic neural network that we have discussed so far, so even your basic neural network was trying to take the input from the current state, right? So this is what we have discussed, x1, x2 and x3. But what if instead of giving this x1, so I'll try to give some other input as well, maybe ht minus 1. So there is one state which I'm going to secure, and this input I'm going to give with x1, with x2, with x3. So what if I can try to give an input in this particular way? And this is where this RNN comes into a picture, or vanilla RNN you can say, a recurrent neural network. This is a vanilla structure which I'm trying to showcase to you. So this is where this a vanilla structure comes into a picture, that instead of giving, so this kind of a neural network, so where instead of giving a input, just a current input, so do one thing. So whatever output that you have received from the previous layer or previous neural, like previous sequences, basically try to include some part of it. Basically, this is what we are trying to call it as a ht minus 1. So technically x1 and ht minus 1 is going to get as a input. And then based on that, we are going to train the weight. Now this is going to give you, so this boxes which I am showing you, right? This boxes which I am trying to showing you. So this is nothing but what? So this is ideally a neural network. Is that making sense, guys, to all of us? That what these boxes are trying to represent, by the way? Yep. Is it making sense? Yeah. So this is what we are talking about, that why to give just a current input. So what I'll try to do, I'll try to give an input even from the previous output. And then I'm trying to say that, okay, maybe in this manner, I can try to train a network which will be able to understand something even from the like a previous output, which I'm trying to provide as an input, and from the current input. Yeah. So maybe it will be able to solve my memory problem. So maybe like I'm not able to retain my previous state, because in this kind of a network, I'm just talking about the output, but I'm not talking about the previous state. So when I'm trying to pass a new input into the network, but here it says that okay, let's like try to pass. So if I'll talk about a vanilla RNN, right? So not much of modification you will be able to see, right? Not much of modification you will be able to see, obviously in its variant, so which is nothing but LSTM and GRU, long short-term memory and gated recurrent unit. So when I will be talking about, so then you will be able to find out that, yeah, so there is something special which people have implemented, scientist has implemented over there. But if I'll talk about just a vanilla RNN, our philosophy is very simple, that some output, right? Some output try to provide as an input when you are going to give an input for the next step. As simple as that. Hope this is making sense to all of us, guys. Yeah, everyone? Yep. Okay. So now I'll try to give you one simple analogy over here. There is different kind of a relationship you will be able to find out. There is something called as one to one, and then one to many, many to many, and many to one. So four kind of a relationship you will be able to find out with respect to the different tasks. But now I'll try to give you some sort of an analogy, that what kind of a problem I can try to solve over here with the help of this kind of a network. Yeah. So let's suppose there is a sentence called as my name is SUDH. Okay. So this is the sentence that I have. My name is Dhanshu, basically. This is the sentence that I have. Now, I wanted to train a neural network. So whenever I'm going to give an input, my name is, so automatically it should do a fill in the blanks. So if I'm saying my name is or name is, so automatically it should be able to do fill in the blanks, and it should be able to generate this SUDH. So basically I'm talking about fill in the blanks kind of a problem statement, and system should be able to do it automatically. But to make such kind of a system, obviously I have to do what? I have to do a training, right? Unless and until I'm not going to do a training, how it is going to be possible? Not possible at all. Yeah. So this is where I can try to use a recurrent neural network. So which will be able to understand a relationship between all of these data set that we have, that which is coming after what, which is coming after what, which is coming before what, and then based on that, it will be able to generate a next sequences for me. Yeah. Vanilla means a stack of RNN, not a stack of RNN, I would say. Vanilla means this simple RNN I'm talking about, right? Which can solve a simple problem, maybe by many to many, many to one. Obviously, it will stacking, maybe we can do it in a horizontal direction, in a vertical direction in case of RNN. Yeah. Okay. So let's talk about this problem statement. My name is SUDH. Okay. So how this RNN is going to help me out in terms of solving my name is SUDH. Let's try to understand that part and how I'm going to perform this kind of operations with respect to the RNN. So first of all, when I say this my, right, when I'm saying my and then this name and then this is, let's suppose, and what is the outcome which I am expecting? So the outcome which I am expecting is basically SUDH. So this is the outcome I'm expecting. And let's suppose this is my X1. So this is my X1 and this is my X2 and this is my X3. So this is the data input which I am trying to provide over here. As simple as that. This is the data set which I am trying to provide in this particular place. Okay. So once I'm going to provide this my name is, and I'm expecting this as a Y. So this is my X and I can say this is my Y. Okay. This is my Y. So system has to learn that when someone says something like this, not just exactly the same word, because I can say my name is in maybe like 1,000 other way. So system, I'm just talking about one line of data over here, but yeah, so in general, in practicality, so you will be not just using this 3-4 words over here. So you will be using a huge amount of the data. So from huge corpuses, it will try to learn. But as of now, I'm just trying to give you the analogy in this particular place. Yeah. So here, right? So here, what will happen is that this X1, right? So this data X1 will go into one of the network, a neural network, I can say, right? A neural network, I can say. So forward neural network, let's suppose I'm trying to send a data. Okay, so this neural network is having some sort of a specialization. So this neural network always try to take a data input. So for example, it is trying to take a input as a X1. That's completely fine. But it is also going to take a input from the previous state. And that we try to say as, let's suppose, a H, right? We are representing that as a H, previous hidden state or something like that. We can try to represent, right? Then so there will be like a X2. So again, we will be having a forward network, let's suppose over here, right? Forward network. And again, from the previous layer, so it will be expecting some sort of a input, so that it can understand what is the relationship between my and name. So this is just a network and then there's something which it is going to do. Then there will be let's suppose again a forward network in this particular place, and then it is going to take some input along with this current input. So every network is now taking two inputs, one from current and one from the previous one. And then in this way, we are trying to build this entire network. And then finally, right? So finally, so this is going to give you something as a Y. This is going to give you something as a Y. So this output at maybe like a time t is eventually is going to be a Y. So this is basically, I'm talking about many to one, means I'm trying to pass many input, not just one input. So many input, it is trying to learn, and then it is trying to give me one single output. One single output it is going to generate. But everywhere, so what we have a neural network. The altered neural network, you can say. So so everywhere you will be able to see the boxes. Now don't get confused with the boxes, because we all understands a neural network very well, right? We all understands a neural network very well. We know that how neural network looks like basically. So this is ideally a neural network which I am talking about. This is ideally the neural network which I am talking about. Now, you can say that you are saying you are going to provide my, right? You are going to provide my. Now, how neural network will be able to understand my? How neural network is going to interpret this word called as my or name or is or SUDH? Because a neural network is basically a mathematical equation, or it's a mathematical network, right? At the end of the day, doesn't matter which network we are talking about, even a convolution, right? Even in case of convolution, so we had basically a kernels are nothing but it's a matrices, right? So when we say we are trying to do a convolution, so we were trying to do a matrix mapping over there, right? When we say we are trying to do a pooling, so again we were trying to perform something like that, a matrix mapping over there. So everywhere, right? So when we are talking about the convolution, or when we are talking about pooling, every time it's a mathematical equation, mathematical calculation that we are talking about. Now, how it is going to do it with respect to my is basically a simple like a English word, right? Maybe I can represent this my by using a different letters in a different languages, maybe a Spanish, maybe a German, maybe Hindi, English, Punjabi, Tamil, Telugu, Bengali, whatever it is, right? Whatever it is. So how this neural network, because I'm trying to say that this is a neural network, right? This is basically a feed forward neural network where you will be having a weights. If you have a weights, you can train it. Now that weight will try to learn a relation based on the input, right? Based on the input, that everything is fine. But let's suppose if this is the neural network, this is the neural network. So this neural network will look something like this, right? So if this is the neural network, then something like this neural network will look like, yeah. So where there will be a input, right? And there will be the output, and there will be the hidden layer. So basically like hidden layer is going to learn something. Output is going to give some output. There will be a loss. Then we'll do a backward propagation. We'll try to tune this particular weight. End of the story. This is what neural network does, right? This is what our understanding is. And here, so we are going to pass like a data x1, x2, x3, x4, x5, and so on, right? Or whatever data we are going to provide this data. So how you are going to provide my as an input inside this neural network? Any idea, guys? So how I'm going to provide my as an input inside this neural network? Any idea? Yeah, that's my question. I believe my question is very much clear to all of you, right? That how I'm going to provide my as an input into this neural network. For example, this is the neural network that I have. Santosh is saying vector embedding. Yeah, so many people maybe are not aware about what is the meaning of this vector embedding. So generally, see, whatever network that we're talking about, it is not going to understand your images. It is not going to understand your speech. It is not going to understand your like letter or word, whatever you are trying to say. Eventually, it will be able to understand everything in a numerical format, everything into the mathematical format, a numerical format, right? Now, what we do is that we will try to convert this my, right? We will try to convert this entire my into a numerical representation. Into a numerical representation, we will try to convert it. Into a higher dimension, we will try to convert it. We'll try to say that, okay, this my can be represented by using maybe some random word 0, 1, 2, 4, 5, 8, 10, 11, 12, 18, 2, 1, right? I'm just talking about the random one as of now. I'll talk about the vector embeddings and everything. Plus even inside the URI, so we have embedding models, which I'm already using inside my generative AI classes. So I'll be showing all those things, all those examples and practical. But first of all, try to understand the fundamentals, because these fundamentals will be with you, like I said in the beginning itself. And believe me, it will help you out throughout your life, not just today or tomorrow, even after 50 years, right? It is going, these are the things which is going to help you out, or even to your kids. So here, what we will do is that we will try to convert this entire my into its vector representation. Vector representation means what? As of now, just imagine that we are trying to take maybe like an array, and inside the array there is some digit, there is some numbers, and then we are going to basically represent this my by using this kind of array. Similarly, for name, we will try to create one array and we will try to represent a name. Now is same thing I'll try to do. And then for even SUDH, we will try to do the same thing. So now that will be, right? So this is the array. This is the array that will be given as an input inside this neural network. I think we all are aware about the batch size, right? So it depends upon the batches. I'll try to like send the data, right? I'll try to send the data inside the neural network. Now, while I'm sending a data into this one, So if it is a normal like vanilla neural network, if I'm talking about, that's fine. But here, so we are trying to add something more. So we are trying to add something more. So we are trying to add more vector, right? So we are trying to like add more vector. And what is that vector? So an output from the previous state. Output from the previous state. So we are trying to pass the original input x1, let's suppose. So this is the original input, and then we are trying to add something from even a past. That okay, let's take this as a data, right? This as a data, and then try to train this entire model. And that's where this RNN is different. This RNN will be able to understand something even from the before, something even from a past. This particular RNN will be able to understand. Is it making sense to all of us, guys? Are you able to understand little bit of like how RNN will be able to like, build the state, or it will be able to understand something from a past? Maybe little bit something. Are you able to understand? Yep, everyone. Yeah, Amrinda is saying yes. What about others? So not a very complex, it's very technical, very logical, things that we are trying to discuss over here. Durgesh is saying yes. What about others? Other people are sleeping or something? Ganesh saying yes. MCK yes. Dev Kumar yes. Okay. Okay. Understood perfectly, sir. Okay, that's great. Now move ahead. So this is where, and this is what I was talking about this. So when you say these boxes, right? So don't get confused. Even over a internet, when you will see on a Google search, so you will be able to see this box kind of a things. It's a bit confusing, right? It's a bit confusing and overwhelming for us that what this box is representing, right? Nothing. This neural network. Now we know that what is the specialization of this neural network. So this is taking this data and this data. So like current data and the past data, right? How I'm trying to represent my current data. So this is how we are representing the current data, how we are representing the past data. So again, in terms of our array, we are going to represent the past data. So now things, and I believe your mind will be clear, right? Now, so we are trying to connect this one with the next neural network, with the next neural network, with the next neural network. And if there is a neural network, obviously there will be a weight, right? Obviously there will be a weight. Obviously, if there is a neural network, obviously there will be a weight. And if there is a weight, it simply means that in a backward propagation, so I'll try to train it. Train it means I'll try to change those weight based on the losses that we have observed. And this is what is called as learning, by the way, right? This is how we say that okay, fine, we are trying to learn something. So this is where, guys, this RNN will come into a picture, right? This is where this RNN will come into a picture, and then eventually it is going to help you out in terms of like learning anything and everything that we are looking for. Okay, so this is one kind of a neural network that we are talking about. But like I said, so this is basically a many to one. This is basically a many to one. So many input and then one output that we are talking about for this kind of a task. But there is something called as one to one. There is something called as one to many. There is something called as many to one. There is something called as many to many. So such kind of a even network exists. And again, it's not about a network which exists. The base model is going to be just this one. Base model is going to be just this one. So we can try to stack it in a way that we want. So it depends upon the use cases that we are going to solve, right? Depends upon the use cases that we are going to solve. So if I'll talk about like a one to one, right? Part number one. So if I'm going to talk about one to one, one to one means what? So one to one simply means that we are having a network. So we are trying to pass input, like suppose x1 over here, and then we are trying to get something from the previous one, and then we are trying to generate the output at time t. So x at time t. So this is basically, right? This is basically a one to one. So one input and one output, right? One input and one output. So the image classification, right? Image classification that we have talked about. So over there, we are going to provide one input and we were able to get one output. But yeah, so if we are going to build a state like a RNN, so where we are trying to pass something even from the past, then in that case, we can say it's a one to one. But one to one is not really going to solve any kind of a problem for any one of you. So now let's talk about a second kind of a network. So base network is going to be same. Base network is not going to change at all. Second kind of a network called as one to many. As its name suggests, so what is the meaning of one to many, by the way, and what this one to many is going to do? So obviously it is going to take one input and then it is going to give you the multiple output at any point of a time. So what is the use case for this one, for one to many? So let's suppose if I'm going to give one single word, right? Maybe I'm going to give one single word as a motivation. So motivation. And then I'm trying to build a neural network, a recurrent neural network basically. So which will be able to generate a complete song on top of like this particular word which I'm giving, right? So in that case, it is going to be one to many. So input is going to be only one and then output is going to be like a multiple. So in that case, in one to like many, whenever we are talking about one to many kind of architecture, so in that case, you will be able to find out that we have a multiple neural network, but we are just giving an input to the one and then everything is connected to each other. Everything is connected. But yeah, so we are getting multiple outputs. So we have basically output number one, we have basically output number two, we have basically output number three, and we have basically output number 4. So let's suppose I'm giving a motivation as an input, right? Motivation as an input. So it should generate output 1, 2, 3, 4. So based on this input, so it should generate maybe motivational keyword, maybe motivational song, something like that. So this kind of a use cases, but base model is same, right? Base model is completely same. We are not changing our base model at all. Now there is an example of many to one. Many to one means, again, similar kind of a network, you will be able to find out many to one. So here you will be able to find out a similar kind of a network where I'm going to give a multiple input, right? So x1, x2, x3, x4, x5, and obviously all of this will be connected and many, and then maybe finally it is going to give me one output. So I believe I have already given you the example, this example, many to one example. So this was basically a many to one example where I'm giving like a my name is and sentence completion basically, right? Or fill in the blanks kind of a things. So many to one, or maybe if I'm trying to perform maybe a sentiment analysis, right? So I'm going to provide the sentence over here and then I'm trying to say that, okay, so try to give me like a sentiment analysis, maybe a positive, maybe a negative, try to give me in that particular way. So that will be basically a many to one, or even like a fill in the blanks that I talked about. So even fill in the blanks is basically many to one kind of an example. Now there is another one. So this is basically many to. So this is basically a third type, many to one. Many input, one output. I believe sentiment analysis is one of the example. Yeah, sentiment analysis is one of the example. I think I have already mentioned that, right? Then there is a fourth kind of a things you will be able to find out, many to many. I think it's pretty much clear, right? That there will be a multiple output and then there will be a multiple input and there will be a multiple output at the end of the day. So here, let's suppose I'm trying to give maybe x1 connected to this one, then I'm going to give maybe a x2 connected to this one, I'm going to give maybe x3 connected to this, connected to this. So now I'm going to get maybe a output 1, I'm going to get maybe a output 2. So here multiple input, multiple output, right? So this is basically something called as many to many at the end of the day. Many to many, basically a neural network I'm talking about. So where I'm going to give a multiple input and then I'm going to get a multiple output. For example, if I'm talking about a sentence translation, so maybe I'm trying to translate my English into Hindi, right? So obviously I'm trying to like speak into English. I'm trying to give input in a English like my name is, and then it should give me a output, right? Mera naam and kind of hai, right? Something like this. Something, so mera naam, output 3. So it is supposed to give me the output. So my name is, if I'm going to give an input, so mera naam hai. So kind of like output I'm expecting. So again, it's a many to many. So many input and many output I will be able to get. Sir, is many to one means we give the same sentences to the many input neuron? No, many to one means, see, depends upon the token. So if I'm going to consider token is equal to sentence, then 1x1 is going to be the entire sentence. If I'm going to consider token is equal to word, then it will behave in that way. If I'm going to consider token is equal to paragraph or the entire book, it is going to behave in that way. So when I say x1, so here I'm considering x1 is equal to one token, which is like word representation. But again, this is not hard and fast. Going forward, I'll show you the example and you will find out a lot of examples out there. So where this entire sentence can be one single x1, entire paragraph can be one single x1, entire books can be one single x1. It just depends upon my interpretation that what I'm going to consider as a token. But yeah, in general, like one word is considered as a one token in general again. In general, but not hard and fast. Fine, guys, making sense to all of us? Yeah. So any question, doubt, if you have, please let me know. Yes, guys, anyone? Doubt, question? Satos is saying, sir, can we completely rule out the time series model like Arima, Sarima? Yeah, you can completely rule out those models basically, because when you have a RNN, right? So RNN will be able to solve things in a better way without much of like doing a statistical interpretation on top of the data. And again, we have a profit from a Facebook, right? So which is again better because it's a deep learning based neural network. So I always advise and always suggest go ahead with the deep learning based neural network, and to time series RNN is one of the best. Yeah. No. Fine. Any other question, guys? Any other question? H0 will always be empty, right? Yeah. So there will be some starting point. So at the end of the day, like if there is a starting point, so obviously for a starting point, it is not going to be like any value. Okay, just give me a moment, guys. Kaju is here, so let me take him out. Otherwise, he will keep on shouting. Just a minute. Yeah, just to answer your question, okay, I was on mute. Sorry, because he was shouting. So yeah, H0 is going to be typically like we are going to initialize it, so we are going to initialize it as a 0. Simple. I think I have unmuted myself, so now I am audible to all of you. I have just muted myself because of like Kaju. He was like shouting a lot. Okay, so now many to one. So this is like a RNN that we are talking about, by the way. And there are so many use cases that you will be able to find out in terms of like solving it with the help of RNN. But yeah, time series. And again, so if you will check your syllabus, so I have added one project in your syllabus. So I have added one project, and that project is basically a time series project. And that problem I'm going to solve not by using a ARIMA, SARIMA or such kind of a model, but here, as you can see, implement end-to-end forecasting pipeline for financial data using LSTM and ARIMA model to predict the trend anomalies. Majorly, I will be using LSTM over here. So to do this kind of a prediction, but yeah, so we can do a comparison with the ARIMA model, that how good the ARIMA is and what kind of a effort does it takes to like build the model, and again parallelly with LSTM. But majorly my focus will be on LSTM while solving this particular problem, this particular project. Yeah, so that's the reason. So I have added this one so that we can even pick those kind of projects over here. Okay, now moving ahead. Now inside this RNN, right? Inside this RNN, so this is the vanilla RNN. Now inside this RNN, so people have basically like came up with a different kind of a network design so that it will be able to retain the memory. It will be able to understand a context for a longer period of time. And that kind of a network is called as RNN LSTM or RNN GRU. So now let's try to understand that where RNN LSTM stands for, and then like how RNN LSTM is going to work, how it is going to help you out. And then we will try to understand how GRU is going to help me out. So let's move ahead, guys, and let's try to understand now a variant of RNN, a variant of the same network called as RNN LSTM. Now, the full form of RNN is recurrent neural network. I have already mentioned. Now, full form of this LSTM is long short term memories. So this is the full form of basically the LSTM that you will be able to find out. So now let's try to understand that what is this RNN LSTM and how it is going to enhance the capabilities of RNN. And it's going to be a little bit like complex as compared to the RNN. I'll try to write a couple of formulas as well. There are 3 gates which exist inside this LSTM. So I'll be talking about all of these 3 gates as well, and what these gates are eventually going to solve, what kind of a problem these gates are eventually going to solve. I'll be talking about all of these things. So are we ready, guys? Shall we move ahead? Or like, do we have any question from RNN? So if you have any kind of a question from RNN, a vanilla RNN by the way, let me know. Okay, so I don't think that people have any kind of a problem. So if we don't have any kind of a problem, let's move to the next one. Straightforward, let's move to the next one, and then let's try to see that what RNN can do it. So when we say that there is some spelling mistake, it's the SHORT. Yeah, long short-term memory. So MEMORY, I can say simply, not IES, not a plural, singular only. Okay. So long short-term memory. Now here, so what I will be able to achieve with the help of this LSTM, let's try to understand that part. Now, before understanding this LSTM, so first of all, we have to understand its design, its entire architecture. So first of all, I'm going to draw the LSTM like a design, the architecture, and then eventually we'll try to understand that what is going to do what at the end of the day. So let's see. So here, if I'll talk about this RNN LSTM architecture, so it's very simple. I would say So any kind of a RNN is going to take two inputs, one from the previous state and one from the new state. So obviously I'm going to provide two inputs. So one from h t minus 1, let's suppose, and one is x at t, current time t. So a current input and the previous input. Now once you are going to provide this kind of a input to the network, so inside this LSTM, so it's researcher, so this LSTM was released in 1997, by the way. So it's like a 1997 means what? So we are talking about a 28-year-old model, right? So this was first time introduced in a market, introduced in a like a introduced to a globe in 1997. So here there will be the input from the previous state and there will be an input from the current input. Now people said that inside this, let's try to build not just one single neural network. So let's try to build this RNN LSTM in such a way that it should be a combination of a neural network, right? So far we were talking about, if I'll talk about one-to-one, so it's a single neural network. But if I'll talk about a one-to-many, so can I say that we are talking about a sequence of a neural network over here? Yeah. So this will be one, this will be one, this will be one, this will be one. So can I say that I'm talking about a sequence of a neural network? Again, so here I'm talking about a sequence of a connected neural network. Here I'm talking about the sequence of a connected neural network. Now, so again, in case of a RNN LSTM, they said that inside this one single block that we are going to create, only one single block that we are going to create. So that one single block itself will be having a different kind of a neural network with a different kind of a roles and responsibility, right? Roles and responsibility. Now, keeping that in a mind, so people have designed three different kind of a gate. One gate is a forget gate, one gate is input gate, one gate is basically output gate. So let's try to understand those gates one by one. So here, the very first gate is basically, they called it as a forget gate. They called it as a forget gate over here. Okay. So again, when I say this forget gate, so technically I'm talking about one of the neural network. But yeah, wait for some time, you will be able to understand in a better way. Cross, and then this is the memory layer, C T minus 1. T minus 1. And then this has been named as a forget gate, F of T. F of T. Okay. Now there is another gate that you will be able to find out, and that is basically a input gate. So this is the design of LSTM. You all will be able to find out. I think this design is visible. I'm not like hiding it with my face. Yeah, let me shift my face on the other direction. This is basically HT minus 1. HT minus 1. Okay. So now nothing is hidden. Everything is visible to all of us. Okay. So let's try to understand that how this architecture is going to work and how it is solving the problem. But yeah, this is how this entire architecture is look like. Don't get overwhelmed by looking at this architecture. It's very simple to understand. And once I'm going to explain you, you all will be able to understand it in a best possible manner. So let's try to understand, and please try to draw this architecture at least once or twice by yourself. You will be able to learn a lot. Believe me, you will be able to learn a lot over here. So let's try to understand one by one this entire gate, and then let's try to understand that how these gates are going to solve the actual problem. So how this this entire neural network, or like a recurrent neural network LSTM that we are talking about, so this is going to solve the entire problem at the end of the day, which was introduced in 1997, and there was 3 gates in general you will be able to find out. So there is something called as forgate gate, so this one I'm talking about. There is something called as input gate, so this one I'm talking about. There is something called as like a update, so here is the update into a memory. So you can say this channel C channel is equal to memory channel. And there is something called as output gate, so which will be able to give you the output h of t, let's suppose. Okay, so like I said in the beginning itself, that this RNN LSTM is nothing but it's a combination of a multiple neural network, and every neural network will be responsible for doing some of the task, right? So one will try to learn what to forget, what to retain. One will learn what to take input and what we should leave. One will learn that what to give the output. As simple as that. And everything is connected with each and every one. So this is where this 3 gate has been designed. And then they have combined it together, right? They have like a club it together by using this multiplication and plus, as you can see. And then they call that as a long short term memory, right? So long short term memory. So a very long short term memory, it will be able to retain, as its name suggests, right? A very long sequence of, for the very short period of time, I will be able to store a memory. This is what it means, by the way. Okay, so one by one, let's talk about forget gate, and then let's talk about basically like input gate, and then talk about basically a output gate in terms of its mathematical equation. So by which you will be able to understand things in a much better way. Yeah, things in a much better way. So here, but before that, let me give you again quick recap about the analogy. So let's suppose we have a neural network over here, guys, right? We have a neural network. So we are going to give our input over here, right? Let's suppose we have input is equal to x1 and we have input is equal to h1. And then we have basically output over here, and then we have some sort of a function in this place, right? Some sort of a function. I'm just trying to represent that function as a sigma, right? So as a sigma, I'm going to represent. So let's suppose some sort of a function we have in between. So what will be the output, by the way? So if I'm going to ask you a question that try to write the output. So how you are going to write the equation for the output? x1 h1, and obviously let's suppose we have a weight for x and we have a weight for h. So if I'm going to ask you that try to write the output, just try to write the output. So how you will be able to write the output? So can I say that inside this function, so whatever function that we are going to use, whether it's a sigmoid, whether it's a hypertangent or whatever it is, right? So whatever function that we are going to use, which is like a sigma. So this function will take input. So input of what? So x1 w of x plus h1 w of h, and it is going to pass inside that function, and eventually that will become the output. Can I make the statement? Let's suppose we have our biases over here. So in that case, even biases will be added. Let's suppose if we have a biases, in that case, obviously biases will be also added. That is anyhow we try to consider it, right? So whenever we are trying to train the neural network. But can I say that this is the function which will give me the output? Anyone who is having confusion with this function? Because I'm going to use it a lot now. That's the reason. So before that, I've just explained you with the simple neural network. Yep. Everyone, is this clear to all of us? Yes, is it clear, guys? This function. So let's suppose if I have a simple neural network, then this is the function which is going to represent technically the output. Yeah, technically this is something which is going to represent as an output. Okay, now remember it, and I think we don't have to remember. I think like we all are aware about it. Okay, now let's come to this one. So I'll come to first of all a forget gate. Yeah, so I'll try to discuss about a forget gate first. Now, if you can see over here, this is a neural network, guys. Consider this as a neural network. Maybe you can consider replace this with this kind of a circle, and you can consider this as a neural network, because this is actually a neural network that we are talking about. This is actually a neural network. This is actually a neural network. Now, this neural network unit depends how many hidden layers we are going to consider. So everything I can customize it even, right? I can even customize it that, okay, this is the number of hidden layer. This is the number of this layer, that layer. This is the output function. Everything I can customize it, right? So everything is under my control. Now here, right? So here we are trying to pass what input. So can I say that this neural network, the FT, the forget gate neural network, is trying to take two input, one from HT minus 1 and one from XT. So two input it is trying to take. Inside this one, it is going to apply some sort of a function. If it is a complex neural network, eventually it's an equation, right? Even if it is having a multiple layers. So it is going to apply, and then it is going to give you some sort of a output, right? Some sort of a output it is going to give it to you. Okay, fine. So if I have a neural network, over here, so obviously I will be having a weights, right? Obviously I will be having a weights. Weights means weight matrices I will be having. So I can try to write this forget gate equation. So FT equation, I can try to write it down in this way, that HT minus 1, and then XT will go as an input, right? Will go as an input. It will try to multiply with a weight of forget gate, plus biases will be there, biases of forget gate, and then it is going to pass it inside some of the functions. So can I write down this entire forget gate output in this particular way? Why I'm considering a weight like WF over here and BF over here? There will be a multiple biases. Depends what kind of a neural network we are going to consider. So maybe my neural network is having this kind of a depth, right? This kind of a depth. So there will be like multiple weights and biases over here. I'm just trying to represent everything with what? I'm just trying to represent everything with one single weight matrix. That's it. And one single bias vector. That's it, right? That okay. So this is going to be basically a forget gate. Now, so what will be our roles and responsibility of this forget gate? So this is going to be FORGET, forget gate. Now, what will be our roles and responsibility of this forget gate? So it will always try to learn to decide what to discard from the memory. So it will always try to learn what? So learn what to discard from memory. Means what to forget basically, because I can't like keep all the context. Maybe like let's suppose if I'm trying to give a class today, so it's not like I will be keeping a context even from my very first class. Maybe I'll keep a context, but a fraction of context, but majority of my context will be coming from where? My immediate last class, right? My immediate last class. That okay, fine. So this is what we have discussed in my immediate last class. Now I'm going to like give now, I'm going to take a class now based on the previous like classes that I have taken. So I'm just trying to, what I'm trying to make a statement over here is that I will always try to refer to my current memory, right? A current immediate memory as compared to a like a kind of a memory which I have exercised maybe in a like a deep past or maybe like a long back, right? So this is what I'm trying to say, that this is forget gate will try to do what? Forget gate will help a network to forget. So this is the output I will be able to get from FT. Now, as you can see that this output is getting multiplied with what? A memory. So this will be the memory till previous time stamp, right? Till t minus 1. So if I'm talking about current time, so till t minus 1, this is the memory. Now I'm trying to multiply, right? Now I'm trying to multiply with this one, and so that it will help me out. So let's suppose my previous memory is equals to 2, right? My previous memory is equals to 2. And now if forget get is trying to tell me, right, I'm just trying to give you a layman analogy again, right? This is not how calculation is going to happen, but yeah, I'm just trying to give you the layman analogy. That forget get is going to tell me that 0.01. So can I say that this multiplication is going to reduce the overall value of the previous one of the memory? But initial time memory, see, don't talk about the initial time, because obviously initial time, I have not given h of 0 or something, right? Over here I'm talking about t. So obviously initial time for the very first time, or when you are going to pass a very first time a data, everything will be equal to 0. Your weight will be random. There's nothing to learn on. There will no data. But let's suppose I have already passed a data information. Let's suppose I have passed my name. My name is Ranshu. I have passed. Then what? Then it will be having some memory. It will be having some calculation. So obviously initial time h of t minus 1 is going to be absolute 0, right? Ct is equal to absolute 0. But when I'm going to pass the immediate next word, I will be having both of these things. Yeah, obviously initial time everything will be 0. That's like very pretty much understood for all of us. So now let's suppose forget get is going to give me like a 0.01. So here I'm trying to diminish the value, overall value of a c. Right, overall value of the c means the previous value of the c. I'm trying to reduce the previous value of the c over here. If forget get is going to give me like a 2 into 2, so in that case I'm going to enhance it. But yeah, so this is what forget get will try to learn, that how much we have to reduce from the previous memory. So if it is going to give me some fraction, right, so obviously the previous memory will be reduced. And then you will be able to see we are trying to even add, because we are forgetting something, right? But at the end of the day, we have to build even a new memory. Agree everyone? The very first gate I'm talking about. So this gate is doing a multiplication with the previous memory. So obviously it is going to reduce the values, means it is trying to like diminish the previous values. But at the same point of a time, I have to even build a new memory with my current information, with my current data. Now this is where this plus will come into picture, and this will get an input from this input gate, right? This input gate. So this is the forget gate, guys. And as you can see this equation, right? Equation is pretty much straightforward, but always keep one thing in mind, that it's a neural network which I'm talking about. It's a neural network. So the box which you can see, it's actually this one, or even bigger than this one. Depends what kind of a network I'm going to set up in between. But what is the responsibility? So this network will learn, right? This network will always try to learn in its backward propagation that how much we are supposed to forget. Is it making sense to all of us? So this gate was designed with that purposes. Then let's come to the next gate, which is basically a input gate over here, right? So which is basically a input gate in this particular place. So it always try to decide that what kind of a new information I will be able to store into the memory. So this input gate is going to help me out in terms of building a new memory, because I'm trying to reduce the previous memory. Now I have to build a new memory so that I will be able to reply better, right? Because whatever I'm trying to say now, this at this moment, obviously I'm able to like continuously I'm building some memory, right? That's the reason. So I'm able to say a next word or next sentence, right? That's the reason. So I'm able to give you the lecture, and that's the reason. So you guys are able to attend the lecture. Let's assume a situation. Let's assume a scenario that in a very first hour of this lecture, you have not even like given attention, or you have not joined in a very first hour of the lecture. I have started lecture at 11:30, and let's suppose you have not joined. You have joined at 12:30, right? You have basically like joined at 12:30. Will you be able to like give me the answer if I'm going to ask you some question with respect to a network? No, obviously you will not be able to like give an answer. So in a similar manner, so basically you will keep on forgetting the previous one, and you will keep on learning the new one, right? It doesn't matter whether you have joined a previous Sunday's class or not, because it's completely fine. We are building a new memory now, right? We are building a new memory now, and we are trying to forget what I have discussed in my previous class, like last Saturday classes. And as we are progressing in this class itself, so we are trying to forget that, okay, what I have discussed in a very first hour of the classes. the kind of introduction which I have given to you. We are trying to build a new memory, right? Every minute we are trying to build a new memory. So this gate is going to help me out in terms of building the new memory. This is where input gate comes into a picture. So let me write it down. Let me delete this one. I'll write it down here itself. Okay, so let's talk about a input gate. Input gate. Now what it does, by the way, so input gate always try to decide a new information to store a memory. So this gate decide okay. So what is a new things that I have to store inside the memory? This is where this input gate comes into a picture. So let's try to understand again by writing an equation. So here you will be able to find out IT, right? Input. And then, so here you can try to say that this is basically CT delta, the output that you will be able to get over here. Now everyone is taking two input. So even this gate and even this gate, even this is the neural network, even this is the neural network, right? So everyone is going to take a new basically input. So if I'm going to write the equation, so here this IT, basically this one is nothing but HT, then weight under like this one, sigmoid function. So here I can write it down in this way that weight of this input into H of t minus 1 X of t plus bias for the input gate. And then CT delta, the memory, intermediate memory that we are trying to build. So it's nothing but a tan H. And then we are trying to pass a weight H of t minus 1 X of t. Same input will go, and B of C of delta, it will be able to take. So this is, right, this is the output which I will get here and which I will get here. Yeah, this is the output. So we are trying to take a hypertangent. We know that whatever output it is going to give, right, whatever output it is going to give, it will be between -1 to +1. So this is going to be the ranges. And this input gate is going to give me some data. Now this like hypertangent is going to normalize it between -1 to 1 at the end of, this is going to give you like something between -1 to 1. So whatever we are going to get, we are going to multiply it together. So basically this is going to give you IT into C delta T. So multiplication of this, and this is going to be added over here inside the previous CT minus 1 after the multiplication that we are able to get. So this will be added over here. So now this is going to build my new memory C of t, right? So this equation is pretty much straightforward, right? Pretty much straightforward. But when I say this one, I'm talking about basically a neural network over here, right? So I'm talking about basically a neural network in this particular place. So new CT, right? New CT, if I have to write maybe this new CT, so new CT is going to be what? So first of all, right? First of all, old CT into FT. So new CT is what? New CT is nothing but, so if I have to update my CT, so old CT minus 1 into FT plus, so IT into C delta T. Can I say that this is going to be the new CT, guys? This is how we are updating the CT. Yes, everyone. Yeah, this is how we are updating the CT. So the cell state update, basically CT is nothing but cell state. Basically it's responsible for memory. So this is how we are updating the CT. Okay, so this is how we are trying to update the CT. Now there is a third gate you will be able to find out. Now this third gate is basically an output gate. This third gate is basically an output gate. which will be eventually responsible for giving you the output. Yeah, which will be eventually responsible for giving you the output at the end of the day. So here you must be able to see OT, right? OT. Now OT is coming out of this neural network, Now this neural network is taking two input, HT minus 1 and XT. So let's try to write down output of OT. So this output gate, so here if I'm going to write OT, so OT is nothing but again like a similar kind of a thing. So wait for OT, you can say into H of T minus 1 and X of T, we are going to pass plus biases of this O. So this is going to be OT. This is going to be my OT. Now this is not going to be my output, by the way, right? This is just going to be my OT. This is not going to be the output, by the way. Now my HT is going to be my final output. So when I'm trying to give you some output, right? When I'm trying to give you some output, so can I say that I should even consider a memory part? I can't go ahead and give you the output based on the like a previous input and the current input, right? So whenever I'm trying to give you the output, so I should also consider the current memory that I have built. Yes, everyone? Yeah. Can I make a statement over here that whenever I'm trying to give you the output, so obviously I have to consider even the previous memory that we have built? Yep, everyone. Yeah. So this is where this HT comes into a picture. As you can see, right, this is where this HT comes into picture. Now, what is this HT, by the way? So HT is nothing but OT multiplication and data that we are getting from the memory channel, right? The memory update that, because before giving you this, we have updated our memory with the current information, and we have even updated our memory that what I have to forget, right? What I have to forget. So this is where things will come into picture. So let's try to understand what we will be able to get here, right? What we are now able to understand what we are getting here. Now let's try to understand what we will be able to get here. And then we are just trying to do the multiplication. So what we are going to get here, it's very simple, right? Again, a neural network. So here I can say that we are going to get basically like a HT as an output. So HT is nothing but OT multiplication hypertangent of, can I say, a CT? And we know what is CT, by the way. So can I say hypertangent CT, right? This CT. So hypertangent, we know this is the CT. This is the CT equation. So hypertangent of CT we will be able to get, and this is going to be my HT. So this is going to be my final outcome, by the way. This is what I will be able to get the output get. So if I'm going to summarize this entire network, right, the one single block I'm talking about, only one block I have discussed over here. So likewise, you can try to stack up multiple blocks in one-to-one fashion, one to many, many to one, and many to many. That's the reason. So before that, I have discussed many to many, one to one, one to many, all these things. So I have just talked about one single block. So this architecture is all about one single block, right? Likewise, I can try to keep any number of blocks, and just imagine like we are trying to introduce like a 3 neural network in one single block itself. And if we are going to take a multiple blocks, how powerful this model will be. And this is where this like LSTM has proven like a solid result. LSTM has given the solid result basically. So if I'm going to summarize it, so here we have basically like first for gate, or when I say gate, it's a neural network, help to forget the previous info. Second, so basically input gate. What input gate does? So decide what new we have to add to memory. Then third one, a memory state of cell state, I can say. Cell state basically. So it will always try to like update the memory. and then fourth one is basically output gate. Now what output gate does, so basically like output gate always try to like tell you that what data you will get from current input and memory basically. So these are the only things that you have to decide, and equation wise, so I don't think that anyone should remember this equation, because I think if you remember this, like logically, if you're able to connect, you can write the equation in no time, right? But yeah, under the hood, you have to understand what is going on. What is going on? Because this is where many people fail. Many people think that okay, this box is right, so maybe they are taking some functions or something. Like a lot of like I have seen people like whenever I ask people, right, that okay, tell me like what is here, and maybe try to give me some sort of elaboration about that. People fail over there, right? Because they think that okay, this box is I don't know, like some function is trying to take some input and output is trying to give, but yeah, technically it's a learning, right? It's a gate. It's basically a neural network. This is where the actual learning is going to happen, and we all understand what is the meaning of the learning. We are going to change the weights, basically. That's called as learning. We are going to change the biases. That's called as learning. So is this LSTM fine, guys? Now where I can use this LSTM? So use case, basically. Use case, right? So obviously I can try to use it in terms of language modeling. Second, text generation. Third, time series or stock price prediction, I can say. Stock price is like one of the specific use case. Stock price prediction. Then the fourth one is speech recognition. The fifth one is sixth one is time series. So, and again, there are like an infinite number of use cases you all will be able to find out where you can try to make use of this RNN LSTM. So I've just written a couple of things, but yeah, there are like so many things that you can do it with respect to RNN LSTM. So now guys, tell me if you have any kind of a question with respect to this network. I'll clarify. Yeah. Anyone who is having any confusion? Single word sent to all gate at a time. Exactly. A single token, I would say more precisely, because when we say a single word, so basically it's a combination of the character. This is what our brain thinks in general. But in terms of a token, so maybe one paragraph is equal to one token. One word could be one token, or maybe like one particular like a character is going to be one token, or the entire corpus itself is going to be one token. But yeah, so if I'll talk about one single like a gate, so one token we are going to send, whatever may be. Let's suppose you are able to understand just a word, right? Let's suppose SUDH, Sudha is one of the word. So yeah, one word will go at one token inside this entire network, as per your understanding. Yeah. Single word to all the gates. And if you have like, if you are solving like this kind of problem, so accordingly you can try to stack upon it. So if you are solving many to many problem, so 1, 2, 3, 4, 5, 6 gate basically. So 6 such kind of things will be used. So here 1, 2, 3, 4, 5. So 5 such kind of things will be used. 1, 2, 3, 4, 4 such kind of things will be used. As simple as that. So this is just one single unit. Depends upon the task that you are trying to solve. You can arrange it. You can just make the arrangement. So hope it makes sense to all of us. Yep, everyone. Question, guys. Question for me. So if we don't have any question, then we can move to the next one. So which is called as GRU, Gated Recurrent Unit, which is another version of, or like another variant of like RNN basically. They were saying, though we have already had a session on the same topic from you. Yeah, I have already taken like a session in your Gen AI class, because in Gen AI class, so we have started from NLP. So obviously like that was a part of topics. Thanks for giving us the opportunity to attend the new session. Has involved new exploration. Obviously, see, if you feel like I'm not even a robot, right? I'm a human being. So whenever I take a live classes or whenever I do a recording, so in every new recording, you will be able to find out that concept is same, but the way I try to build the surroundings, or you can say analogy, is going to be different. It's not going to be same. Can you explain a bidirectional LSTM in brief? I'll explain you everything. Don't worry. So just like understand this part, because bidirectional is nothing but like just like a two-way. So I'll be explaining you all those things. Let's go in a step-by-step manner. It's not tough to understand. If you are able to understand LSTM, then I'll just add one single line and that will become bidirectional. That's it. Okay, so I think it's 1 o'clock, right? Okay, let's do one thing. I think even Euron has given the answer. Bidirectional LSTM is an extension of the standard LSTM architecture. It processes data in both forward and backward direction. Simple. So like I said, I'll just add one single sentence. I'll draw one picture and that will become like a bidirectional. This is how simple it is. Okay, so let's let me discuss this GRU maybe in the next class. Let me convert these things into a PDF, RNN and LSTM. So I'll explain you GRU and then transformer like in the next class, guys. Those who would like to understand now, so I think I already have a lecture. So I have just uploaded a PDF, the PDF which I have used inside this class. So you will be able to find it inside the chat, guys. So in case of like any kind of a revision, so please try to go through it. And apart from that, so on Euron, now I'm trying to bring a new series, as you can see. Hope all of you are happy about this particular series. A lot of changes we are trying to bring, not just like this series. So inside this series, I'm personally recording each and everything, which is my long-term vision, by the way, that there are like a tech stack which exists. So let's try to record a best premium version of a tech stack with a practical example. So this is what I'm trying to start with this particular series. So 20 courses we have released inside this particular series. You will be able to find out. Now you will be able to find out courses from the big data, from our data analytics, from our data science. Again, I have broken it down into a different section. So machine learning, deep learning, computer vision, generative AI, MCP, agentic AI, everything, right? Everything. So this courses are we are going to start in a hybrid mode. You can go inside all of these courses. You will be able to find out like it's course detail, by the way, right? Everything you will be able to find out here. And just attend as much as you can. So after this series, so again I'm going to bring a new series. So basically the whole idea behind Euron was to create it as a OTT. Again, OTT releases things into a series manner. OTT goes for the subscription. OTT gives you other features as well. So this is where we are heading as of now, you can say. So hope all of you are going to like it. And if you have any kind of a suggestion for me, so please let me know. will try to implement those suggestion inside this Euron platform. But what I want is that your learning should not stop. So I'm going to bring even a ops series. I'm going to bring even a front end back end series. All 20 courses are not visible. So I don't know like whether team is like even working on this filtration side of it. So maybe they have changed a little bit in terms of filtration. Because of that it's not visible, because there are 20 courses that we have released. So yeah, and all these courses you can see even over here, right? Even in this particular place. So anyhow, that we are going to fix it. That will fix it. So yeah, we are just moving towards as a true OTT platform. So people can pay on a monthly basis, on a yearly basis. They can cancel anytime they want, so that they should not take an unnecessary financial burden. Although like ticket size is very, very small, it's like peanut, but still we don't want to like charge even anyone as 100 rupees if it is not worth it for them. And this, if they are feeling in that way, so obviously they can try to cancel it. This is where like our Euron Plus comes into picture. And yeah, so we have Yuri, resume, jobs. Please try out this job feature as well. So yesterday someone in your group told me that we are not getting enough job from Canada region, from a UK region, from a USA region. We have added that as well. So now if you'll go and search, you will be able to find out a job even from those regions. And plus obviously like every day system is giving you a recommendation, right? So here you can go and search and you will be able to find out a job from all the other regions. You can just go ahead with a search, right? And let me know if your location is not added. I'll try to add it so that you will be able to get a job on a regular basis. Plus we have obviously like a resume and many more series. So I'm going to bring even an interview series. So machine learning interview, big data, DevOps, cloud, everything like interview series. We'll try to bring a project series. We'll try to bring the course series we have started. But yeah, so again, next month after June 15th, I have a plan to bring complete cloud series and ops series basically over here. And so that, and plus you will be able to see like a lot of like a changes even in terms of this entire interface plus experiences. Now your Android and iOS app is available. So we are now adding more and more feature inside Android and iOS. So now we are like it's been like a 4, 5, 6 month of time, I think 5 or 6 months of time, but now we are heading towards a fuller scale like a platform, like a journey. Blockchain, sir. Blockchain, I don't have a plan now, but yeah, in future. First of all, I have a plan to complete a major 7 stack. So which is like a DSA, system design, data science, big data, data analytics, front end, back end, then ops, and then cloud. So again, inside that project, then we have to even as of now. So since a very long time, so we have not published any books because we were working on this book feature, by the way, because the reading reading wise, this is not that great as of now, especially in mobile, if I'll say. So we are trying to change this particular experience as well very soon. And very soon you will be able to see hundreds of books, a full scale books, a different kind of a books in a different genre. You will be able to find out with an amazing reading feature, a flip book feature we are trying to implement, where you will be able to get a AI summarizer. It will give you amazing experience on your mobile devices. So even such kind of things we are trying to bring. So soon you will be able to experience even like those things. Santosh saying your class details say I will take a lifetime subscription if available. Lifetime is not available, Santosh. I don't want you to invest on me or my platform for a lifetime. So just invest till the time you want it. And then like whenever you want in the future. And if those things are available, like, because see, I can't give a commitment for a lifetime, especially after like I can't do that. So basically, there is another story for that. I don't know whether you are aware about it or not, but yeah. So I'll not give lifetime at all. That's not good for people. So it's better if we will be connected for a lifetime, right? So I think that will be better, but not like I'll not sell anything like to anyone for a lifetime. How do you learn all this tech in such a depth? What kind of a study approach you follow? I am like building a tech, I would say, since last 11 year, right? This is my 11th year in the industry. And again, it's not just about the number, believe me, right? Like people like me, there are like lakhs of people you will be able to find out who is having like not 11, maybe 20 year of experience. But if you'll ask me, I have invested my complete 11 year in terms of building, even when I was fresher and even now. And since last like a 6 year, I'm an entrepreneur. So even when I was an entrepreneur, means entrepreneur doesn't mean that like you will just go to your office, sit like a boss, and then you will do nothing, and your people will and your like employees will do everything. No, I was not like that. I was taking classes continuously. I was taking classes. I never left like a classes part for like 6 months of time. Maybe last year I was not taking the classes. Yeah, 6 months or 9 months of maybe for a year of time I have not taken the classes. But yeah, since last 8 year I've been taking classes. Since last 11 year I'm building, and even today I'm building a new things. So this is the source of my learning. And I keep on saying this to everyone, that build something, right? There is no end to a learning. Build something. And parallelly I used to teach, right? So when I used to teach, same topic I'm teaching like maybe like since last 8 year in a different way, a modified version of it. Maybe it's a big data, maybe it's a data analytics, maybe it's a data science, maybe it's a DevOps or cloud or any other things, or maybe front end, back end, right? So it will be on your fingertips. Simple. Or DSA or system design. It will be on your fingertips. Because this is what I'm doing since last like 8 year. So I have started with the part-time one as a teacher. My last 8 year back. And then like I became full-time. I became full-time entrepreneur. I became like a full-time developer. So if you are going to follow, there is no shortcut. If you're going to ask me that is this possible in 1 year? Yeah, it is possible in 1 year. You will be able to create a better version of yourself, right? But again, so your benchmark will change by the time you will be like reaching that position. So keep on investing on yourself, right? Simple. I'll say that enjoy the life, and whenever you're trying to work, so work with 100% dedication, 0% distraction. That is going to give you a fruitful result. I'm not saying that just go and work for like a 18, 19, 20 hour a day. No, not at all. I don't even do that. Sometimes I do it because it's a need of an hour, but yeah, not regularly. I just like enjoy my life, spend time with the family, and then like with my team a lot, but not just for work. So we just like do a lot of casual discussions as well, fun discussions we do, and yeah, we build things parallelly. That's it. Sir, no live session after the current batches. As of now, no live session. But again, I'm going to start the live session after maybe like a 4 or 5 month. I'm going to launch a series of live session because I'm the only person. I have like a 24-hour with me, Monday to like Sunday, right? And this is the series I have launched. And like I said, so I'm going to bring more and more series, like an interview series. I'm going to bring other series, project series I'm going to bring. I'll complete this one. That's the target I have given to myself. And then I'll start my live classes once again. So after this 2 batches, I'm not going to take live classes for some time. But yeah, I'm like creating a content on a regular basis. Please tell the story briefly. Okay, so I think you can go and maybe like read out my story here. I have a founder page. So where I have started, at least you will be able to get some idea about these things, about me, like what I have done, what I have built, what I sold, where I have started, and then what I'm doing now. And then like there are a lot of newspaper and media, all the popular newspaper and media, you will be able to find out something about me. So yeah, I think there is enough information available on internet, just all about the Google search. So that you have to do. Santosh saying, want to go show me, please prioritize the including the reinforcement learning if possible. We'll see that there are a lot of demand we are getting from the people, but yeah, like I said, so personally I'm recording everything. I'm not involving any other mentor because I think I should go and do other recording so that people can understand things once for forever. So yeah, I'll do it, but things will take some time, maybe like next 4 to 5 months. A lot of things you will be able to see in terms of courses. To arrange your session to give your valuable insight about the open source contribution. Okay, we'll see. I think like a lot of people have already given advice over the internet, over a YouTube channel. So about the open source contribution. See, it's not about advice. Never look for the advice. Now you have a AI with you, right? So whether you are using Yuri or GPT or Cloud A or whatever. So you have a AI. So when you have a AI, then the question is why you are waiting for me, why you are waiting for anyone else for advice, right? Start working on it. Go over here, search that what an all open source project I can do, I can contribute, how I can contribute. How I can contribute is just a one line of a statement, right? Download, build something, submit it again. maybe start your own open source project. Start like asking everyone that, okay, fine, contribute, right? Maybe start asking for a donation from someone, so that you will be able to get some sort of a earning. Your team member or whoever is trying to contribute with you as open source will start like earning. You can try to just go over here, ask for the steps, right? Maybe in your domain, maybe like with respect to language, you would like to contribute, with respect to a framework, you would like to contribute, with respect to a new research, you would like to contribute, because there are different level of contribution, different type of contribution. Again, that depends upon your interest, right? I'm not going to like say that there is one thumb rule and you can go and apply it towards everything. No, that is not going to happen. So when you have a AI with you, right, which can give answer better than me or better than any human who exists in this entire planet, right? Use it. This is how I do it. This is how I learn. This is how I keep myself updated. Yeah. So taking my insights will allow anyone else's insights, right? Believe me, it's not going to help you much, because that is basically a 10,000 feet of like insights you will be able to get. In reality, value for those kind of insights are zero. Even if I'm going to create a video on YouTube and then say that, okay, fine, do this. This is how you will be able to do a open source contribution. I will be able to get maybe like 10,000 or maybe lakhs of views down the line. But unless and until you are not going to contribute, right? You are not going to start. It's having no values. So start first. And it's very easy to start. Believe me, it's very easy to start. When you have a power of AI with you, it's very easy to start. So just start. Yeah. And then you will find the problem. Then your question will change. Then maybe I'll be able to, then I'll answer like happily, or maybe you will not even ask at that point of time. You'll just go and ask to AI for your next question. So, I always suggest to a people that your growth is always about your mindset. So if you are going to keep a mindset in that way, believe me, you will be able to get things sooner or later. But again, there is no shortcut. So I'll not say sooner, but yeah, later you will be able to get it. So fine guys, with that, thank you so much. I think agenda for next class is we all know. So we are going to talk about GRU in my next class, basically get a recurrent unit. And then I'm going to talk about a mother of all this LLMs that you are talking about nowadays, which is called as attention is all you need, research paper. But again, so those who have attended my previous class, they already know that how I discuss any of this research paper. So believe me, you will be able to understand the way you are able to understand everything till now. So this is what I'm going to discuss in my next class. Attention is all you need. With that, guys, thank you so much, everyone. And see you again next Saturday. Yeah. And we are already connected over WhatsApp. So feel free to ask a question if you have any. And maybe me or someone else from your group will try to reply. So with that, thank you so much, everyone. Take care.